so my plan was to just kind of, I'm going to tell you a little bit about the work I do, and I hope to be able to talk a little bit about my latest project that I've been working on, which involves sort of audio library and an embedded platform that I'm kind of developing to try to making embedded instruments a little easier. So, all right, so who am I? I'm a composer, I'm an improviser, I'm an instrument designer. He already Alex introduced me. But yeah, in general, I'm kind of interested in the artistic use of technology. That's sort of the main thing that I want to do. As Alex mentioned, I made this a while ago, and this is called the Snyderphonics Manta, and it's a capacitive touch controller that I came out with in 2008, maybe 2009, and that's been kind of my most successful project in some ways, where there's a bunch of people who play it, and I sold a lot of them by my standards, not very many of them by any commercial standards, but it's kind of really cool to have people around the world playing them. So so that's one of my kind of earliest completed instruments. There's the little circuit design for it. And recently I came out with this thing called the Manta Mate, which was, so this is 2 years ago. It took me a really long time to develop because I've got the academic job and I'm just slow in general, and I do a lot of different things at one time. But I just came out with this thing, which lets you talk to modular synthesizers with a Manta. And that was actually a really fun project. It's become the second commercial product from Snyderphonics. But it also works without a Manta. It does like a bunch of general digital to analog conversion. So you can plug in a Manta, and so here's a modular, and I can make it control my synth through that. But then I could also plug in a game joystick, PlayStation controller kind of thing. I could plug in a MIDI keyboard. It talks to your computer. You can plug in your computer and control it from MIDI. You can unplug anything from it, and it operates as a sort of clock divider and repeated random voltage generator, stuff like that. So I kind of built in all the different things that I wanted to be in a module of this size.
I was just going to say, I'll be playing it with a joystick.
Yeah, he'll be playing it with a joystick tonight. So, and I'll be playing it with the Manta, and I have 2 of them in my rack, and the other one I'll be using with no input, as a sort of clock generator and stuff like that. So.
MantaMate is a new instrument.
What'd you say?
No input MantaMate.
Yeah, exactly. It's like no input mixer. I don't know. That was a really funny thing about the development. I originally made, my original idea for this was, I'll just make it kind of so you can play the Manta like a keyboard on a synthesizer. But then once I had to design the hardware in to make that possible, then I was like, what else could I do in the firmware? So what else could I make it do? And at the very last minute, like a month before I finalized the firmware, I was like sitting with it in my rack, realizing that it's frustrating when nothing's plugged in over USB and it's wasting space. So I was like, it's a digital input and 12 analog outputs. What else could it do? So then I just tried to think up a whole bunch of other functions. So it's turned out to be one of the main, it's turned out to be the central thing of my performance system since then. So it's really kind of fun. Yeah, maybe I can give a little more demos of that later if people are interested. So I've built a bunch of other instruments over the years too. These are some of the ones that I made. Earlier, like around 2008, 2009, 2010, I was working on these guys, which are these kind of acoustic resonator body electronic instruments. In 2011, I made this thing, which called the Jesus keys, or the JD1. It's called the Jesus keys because it was made as a custom job for someone named Jesus. So the file on my computer was Jesus keys for a long time, and then the name stuck. So, but I like to say it's a accurate reproduction of the keyboard that Jesus played on the cross. So that's how I made it. But that became my live performance instrument for many years now. So basically, It's just this year and last year that I've started not performing with it again, mostly because it's too big to use in carry-on luggage. So I just have started removing it from my rig so that I don't have to worry about not being able to fly with it. And instead kind of moving towards a Manta-based performance environment, which actually the Manta had never really been my own performance instrument since I made it. Other people had picked it up as kind of their main interface, but I always, I made this and I used that most of the time. But now I'm kind of, now that I've finished the MantaMate, it's become sort of more central to me again. I'm going to talk a little bit about each of these because those are sort of a little more recent. This is called the burl. It's my sort of electronic wind instrument. And I'll go a little more in detail on that. And this one's called the drum box. It's my electronic percussion instrument. So I'm kind of trying to work on making a whole range of all of the orchestral instrument types. That's my goal. I want to make an ensemble of all, where everyone's playing all my own versions of all the kind of instruments. I'm almost there. So, all right, so here's the burl. And this is the first burl. It started out looking kind of like this big box because I made it in 2008 or 2009 when I was making those things with acoustic resonators, which I still really like that concept, and it sounds really neat. But I mostly moved away from it due to practical considerations because it was such a pain to travel with giant boxes. But the idea behind this one, this was kind of an unusual instrument. I was really interested in the sound of, actually I was doing, I was playing around with pen plotters a lot. Do you guys know architectural pen plotters? They're like a robot that moves a pen around to draw. And I had a bunch of those, and I set one up with an electromagnetic pickup on the motors so that I could amplify the motion of the pen as it goes X and Y positions. And I'd originally intended that, so I had this band called the Draft Masters with Daniel Iglesias, and we just played pen plotters as instruments. And I originally intended it as just like we were going to send commands to it and then amplify it, that kind of sound. But then once I was debugging it while I had it plugged in to the electromagnetic pickup, and I accidentally moved the arm, and it was this really nice pure sound, which was very different from the driven sound, which when we drive it from the computer, it's this kind of gritty, square wavy kind of thing, but then actually just passively pushing the motor made it generate a really beautiful kind of sine wave thing. Because basically a motor is a generator in reverse. So, they're the same thing. You just turn the shaft in order to get a electrical signal out. So this was my kind of way. I made this thing that's electromechanical oscillator where you turn a motor with another motor. So you're driving one motor and it's on a belt, and it turns the other motor and makes an oscillation. And then for reasons that now escape me, I connected it to a kind of wind-style control. Mostly, I guess it just sounded kind of like a bird or like a recorder or something. It has kind of a pure tone. And it's monophonic because you can only, I was changing the speed of the motor, but it only has one voice at a time. So it felt kind of wind instrument to me. So then I put this motor system inside this big wooden box that was also acting as the resonator. And this was the basic system. Works pretty well, except that the resonator body, it was kind of dumb to put something mechanical inside the resonator body and then screw it in there. So basically, the problem is you can't really, you can do some really nice control. It's really easy to take the electrical signal out of this and then change the amplification to change the volume. You can just, now turn down the electrical signal and it goes to silence. But the mechanical signals, it's still shaking, so the motor is still vibrating. And unfortunately, when it's plugged into a resonator, that means you can never really have silence because you can't stop the motor because you have to ramp it to get back up. So it ended up being a little annoying, and it has this little kind of very quiet sound at all times. So then I made this second version of it where I was like, okay, I'll take the box and I'll make it a separate thing that you plug the wind controller into. And this, so now I kind of separated it, and this thing was an empty resonator, just sending control stuff over MIDI. And I made my box a little more fancy because I could. thought it was fun. So that box looks kind of like this. Here's the little, this is the guts, and then I made a little nice panel for it so it looked all neat inside even though it's not. And here, maybe I can play a little bit about what on earth this sounds like. So. Yeah, so that's a little bit of the kind of sound of this thing. It's basically very sine wavy, but it's got a little more, it's got a little bit of harmonics, a little triangle-y, and the thing that really interested me about it and the electromechanical nature is the transitions between notes. These two sound clips are from a version that I made with a rubber friction belt drive, and basically it has a little stretch, so it overshoots. So whenever a note whenever it moves to a note, it actually like hits a little higher and then comes back down, and you get this kind of real physical change.
Is it to do with the fingering too? Like when I don't know how you have the fingers.
Yeah, in this case, that sample was actually from direct control of MIDI. So it's actually not, but it definitely, with the wind controller thing too, then you have the fact of any kind of like slight glitches in your fingering will also add to it. So it kind of gets compounded by the fingering once you plug it in. Here's like a little version of what it sounds like faster. So you can hear the... Yeah. And I also found it kind of fun to try different types of belt drives. So this one is with a timing belt instead of a friction belt. So it's like gears on the motors, and it gives you a different timbre, and it doesn't get as much overshoot, but it's like sort of like a buzzier timbre because you get it's tiny.
Is it the mechanical noise of the source motor that goes through it?
Yeah, no, it's actually I think it's just the fact that I'm using stepper motors. Okay. So when you have a timing belt, you actually get some of the resolution of the steps, basically, a little more, whereas they're smoothed out by the friction belt. Yeah, and it's really nice. It gives it a brighter sound. It also gives you kind of a weird frequency modulation on the higher frequencies. I don't know why. But anyway, I thought that was really fun. Here's the fast version of the timing belt. Kind of screamy in the upper register, which I like a lot. Yeah. So then I ended up later making a third version of this instrument, which was basically the electromechanical oscillator kept breaking as I traveled, and I ended up sort of trying to make a version of the wind controller that was more general too, which in a way is sort of boring. It's like, okay, I went from this totally weird electromechanical instrument to being like, okay, I just made a copy of the EWI. I don't know, but it's kind of interesting. What'd you say?
A wooden EWI.
Yeah, I made a wooden EWI. There you go. But actually, this is kind of interesting, though. In a lot of senses, it really is just similar to the existing electronic wind controllers. But I wanted to make, one thing I wanted to do differently was to have continuous fingering, so it's a little more like an open hold wind instrument. And that's something that earlier versions of the burl didn't have. They had switches, which are kind of on-off digital, very similar to the existing wind controllers. So then I was like, yeah, what could I do to make it so it felt like an open hold thing, like a bamboo flute or something like that, right? And it's pretty easy to do with capacitive touch sensing technology, which I was already using a lot on things like the Manta. Yeah, so I ended up making this one. But then I got into the problem of, okay, well, if you're going to have this continuous finger sensing, then how do you figure out what note it's supposed to play? And it becomes a little harder problem. And I tried a few different ways. I tried a sort of a rule-based method where it's like you're saying, well, this note drops things a whole step, and this finger drops things a half step or something like that, which works okay, but it's not a super flexible thing because you have to think through the algorithm every time you want to make any little change. And it's hard to then say some other random fingering is going to do something else. So that's where machine learning ideas came in. And actually, Rebecca over here, who's going to tell you about her work in machine learning later, was one of the first people to test this out, where we used her Wekinator program to try to see if machine learning could solve the problem of basically saying, let's train a bunch of different fingerings and then have it figure out what the interpolations are between when you play something that it now hasn't been trained on. Let's see what it does, which actually turns out to work pretty well. And this is someone trying that out. So they're trying the machine learning system out. Oops, apparently it's nothing. Hold on, let me go back. Here. You can see over here the software we made. So he can see his fingerings. And then that's also the way that he can train the different fingerings. This is testing out the bending with the continuously open holes, which is kind of nice. Yeah.
That is beautiful.
Yeah, so that's, I feel like that was pretty successful. It's definitely like, it is just an electronic wind controller too, which is kind of, as I was working on this project, I've been getting less and less interested in making controllers that connect to a computer and talk to computer software, and been frustrated by the controllers that I made, then sort of, having to keep software current on computers instead of just having it live as its own sort of thing that I can still plug in 20 years later and it'll do the same thing. So I started really wanting to make a built-in sound module inside this burl. And I don't know, maybe I'll show one other little example before I talk about that. But this is also the third way that I tried to play around with the fingerings, mapping these continuous fingerings, was to use physical modeling so that you could say, let's make it model an acoustic instrument. And then I was also playing around a little bit with, let's see. So this version, let's see. You can hear he's trying this out. So in this case, he's like playing with the physical model. And I was trying a sensor system to see if I could sense embouchure differences better, so that you could really get timbre change by just changing your, by just changing how you move your mouth around, which is pretty cool actually. I think that works pretty well, but I need to work on the sensing technology. I never really got it that much past that. Yeah, so basically, I got interested in, I want to have them make their own embedded sound instead. This was the first instrument I made that really did that, where I was doing digital audio inside the box. It's called the drum box. I was just trying to make a percussion instrument. Basically, this came out of an instrument that we improvised for the laptop orchestra that I direct. We needed some marching instruments for this marching band we were trying to make. And one thing that we did was we just took a delay pedal, a guitar delay pedal, stuck it in a cardboard box with a piezo mic, and then plugged that into a little portable amp. And then we had something where you could, if you make the delay really short, you can tap on it, you get kind of Carplus strong, sort of super simple physical model comb filter kind of thing. Bang, bang, bang. And I thought it sounded really cool. So I was like, I'd like to make something like this. But then as I was playing around with this type of sound, I was like, it sounds really nice if you take that, but you add like a couple sine waves that are inharmonic with it, then you can get this really nice drum-like sound. So I wanted to make something that could run those kind of processing and not be a guitar pedal in there that I stole, but rather run my own code. So I built a little strip over here that had kind of a little touch controller and some knobs, and then would do this basic synthesis idea that I had. So it's kind of doing like a really simple physical modeling on waveguide thing based on the piezo input. And at the time I was like, wow, this is really cool, nobody's done this. And somebody was like, it's like the Korg wave drum. And I was like, what's a wave drum, And then I looked at it and I was like, yeah, somebody did this 15 years ago, okay. But I still think it's kind of successful, and it is basically like a much stupider Korg wave drum. But in a way, it has a more limited sound palette, which I think is actually really kind of cool. So it's like this thing sounds like it sounds, and that's it, right? And I've been getting more and more interested in that, like limiting the sound palette of the instruments that I make. And part of moving away from controllers, the idea of controllers is to say, okay, how can I make these things really feel like an instrument and not feel like It could be anything. Oh, any sound you can imagine. I feel like that's sort of a false promise of electronic music that it's nice to move away from a little bit. So yeah, here's a little bit of a piece I wrote for the prototype drum boxes. So this time they're just like laser cut wooden boxes here. But you can hear, except for the shake array, everybody's playing these, it's a quartet for 4 drum boxes. And in this case, they have like a knob for pitch. And then maybe here I'll play a little bit of, this is the final version of the drum box with Jason Truding playing it on my album, Concerning the Nature of Things. I put that drum quartet piece on there. Sounds like this in the final, so. Yeah, fast forward a little bit. It's kind of nice. In the upper register, it's sort of, in the upper register, it feels a little bit like thumb piano or something, and lower it feels a little bit like, I don't know, like acoustic drums. Yeah. There's acoustic drums in there too. You can also turn up the feedback and make it do kind of crazy shit, which is fun. Anyway, so yeah, basically, yeah.
We're jumping out of this. So
Yeah, no, go ahead.
Question. We hear a lot of the transient. Is it? Did you mix that back?
I mixed in the actual a microphone recording and the piezo signal, so okay. You're getting a lot of the click too. It's true. So I like that.
Yeah, but I just wondered if it was just the algorithm. Or...
Yeah, no, it's I do think of it as like the instrument has acoustic sound too. So I played around with the surface, making sure making it sound kind of nice with when you strike it, as opposed to just being a rubber pad.
This has like a line out or something in your amplifier.
And you put it through an amp, yep.
Yeah. And what sort of amp would you use?
Yeah, good question. When So uses it, So Percussion, the group that played it on this album, they just have a set of 4 Roland Cube amps that they use for any electronic things that they need. So basically it comes out of their Roland Cube amps. It sounds pretty good.
But you still hear some of the acoustic sounds.
You still hear yeah, exactly. And the acoustic sound's kind of loud enough.
And on the album, did you mic an amp, or did you?
On the album, it's direct, because I really do like the direct sound of them. So, and in the performance we did, we actually also had some little Sunfire subwoofers, which really was nice for the low stuff. It's kind of like makes it feel sort of impossible drum, just like woo, 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 very fun. But yeah. And I feel like this is a pretty successful project, except for the fact that, at some point I was like, oh yeah, I'll come out with this as a product. And I was like, oh yeah, I guess it already happened with the wave drum. But
and the patents.
Yeah, exactly. There's probably patents. Yeah, I haven't looked into it. But it's kind of fun as an instrument for myself anyway. So I'm continuing to write for it. But this brought me towards basically when I was developing the drum box, I was developing for a little microcontroller, and this was maybe 5 years ago, and it was kind of just at the point where it was starting to be possible to do real audio processing on a microcontroller without an external DSP chip. So I'd say 10 years ago, you definitely just couldn't do that. And it's more like, okay, you got a little 8-bit Arduino, or you have a real computer, and it's like, there's a big wide gulf in between them. And if you want to do some audio, maybe it's one of those little 8-bit chips, but it's talking to a DSP that's doing all the heavy lifting. And on this drum box, I used this newer, at the time, chip called the STM32F4, which has become kind of common in a lot of people who are doing digital analog synth modules these days are using that. And it was really fun. The thing was, it's kind of in between a microcontroller and a small computer, so it really feels like it's a really powerful microcontroller without the hassle of all the computer garbage, the baggage that being kind of a miniaturized computer comes with. So I kept changing the drum box code, and then I wanted to do some other stuff with it, and I found my whole workflow was really messy with working with this thing, and I wanted, I kept basically copying and pasting huge blocks of code as I was trying out different things on this chip. And I decided I really wanted to continue doing stuff along these lines. So eventually, I have a researcher who works with me named Mike Mulshine, and he was working on some of the code with that stuff with me, and he was just like, Jeff, we need to organize this. Let's not just copy paste the same code every time we use a filter, and like, you know. And I was like, that's a great idea. So, you know, first thing we did is we were like, oh, are there audio libraries out that we can use that'll run on this embedded stuff? And the answer was basically not really. That served our purpose. So, so I decided to try to set up a little development tool for myself. We wanted to be able to do audio processing inside the instruments, and we wanted them to be self-contained, not a controller. You know, so my options are, do I do embedded Linux computer, like Raspberry Pi, BeagleBone? They're inexpensive and they're small. Or I could do these ARM microcontrollers, and that's these things that the F4 is that I'm using. So we looked into the platforms to say, okay, is the direction we're going, does it make any sense? Or are they, because at the time there were like more options coming out, right? And if we didn't want to continue copying and pasting our code, maybe somebody's made a library that'll work for us. If we wanted to go towards embedded Linux, like right around that time, Andrew had come out with Bela, which is fantastic. And Ed Berdahl made Karma Satellite Pi for the Raspberry Pi. And other people had worked on the ARM microcontroller. Teensy Audio Library is actually based on the same thing. And Axolotl was using an F4 chip as well. If you wanted to use embedded Linux, well, then you can use all these sound programming languages that you already know, Max, SuperCollider, whatever. And it's a lot higher level, which is nice. But you get like a slow boot time, which is really annoying to me. I think a lot of people just doesn't matter to them. It's like, yeah, okay, it takes like, what, 10 seconds, not a big deal. But like, I just find that really frustrating, and I don't think an instrument should do that. It makes me feel like I'm booting a computer, and I don't want to boot a computer. I want to just plug it in and play. So somehow that just like conceptually bothers me. And you just have less direct control of things like timing and memory, because you're always working with an operating system overhead, which the operating system is really handy when you want to be able to actually thread things and whatnot, but I actually generally don't, because I want to know what's happening when. So to me, embedded Linux wasn't really an option. But I'd have to say, for most people, I think it's the best option. Basically, if you're trying to make embedded sound in a little box or device or whatever, unless you have crazy needs like I do, go for Bela. You know, it's like, that's basically like, Andrew solved so many of the problems with it. You know, it used to be, oh, well, there's latency issues, and oh, you know, you can't talk to the audio driver well enough. Well, Bela kind of just, they solved all of that stuff in a really great way. But for me, it still doesn't do what I want. And also, it's a little more expensive, right? So I'm doing this bare metal stuff with the ARM microcontroller. Right now, I'm using the H7, which is, they kind of moved it up, and in the last year, they have this really nice advanced one that's like twice as fast as the F7, which was twice as fast as the F4. And it's like, I can do almost everything I want to do on it now, which is amazing. And then there's no operating system, so kind of cool. So I made this thing, which is this project where I said, okay, I'm going to make my own. Also, you know, you saw the drum box circuit board that I had, and it was like, it's got a bunch of knobs on it. But then when I wanted to change it, it was kind of frustrating. I was like, oh, I have to make a whole new circuit board just for this other, you know, because I want to move this knob over here. And it was an expensive circuit board because it has all the audio stuff on it and everything. So I was like, what I need to do is have a little prototyping system where I have a single board that has the microcontroller and the audio codec only. And then basically, and it's just totally stripped down and has nothing else. And then everything else, I just design any instrument that I'm making now to have the connectors to plug into this. And then that's the sound, right? So then I can just treat it as a separate thing. And I call that little board the Genera brain. And then I develop little panels where then I make a little thing that this snaps onto the back of. And then that gives me knobs, that gives me displays, whatever else I need for that particular project. So here's like a version of it in as a Eurorack module. I just made a Eurorack module panel, and then I stuck my DSP board on the back. You could see, oops, doesn't actually work. Let's make it make sound. Yeah. Woo. So that's just drawing a bunch of sine waves on it.
What's the I/O of that? Sorry,
yeah, what's the what?
I/O.
What do you mean about it?
How many
Oh.
controllers have you got in
It's just 2-channel. So basically, the codec I'm using is 2 channels in, 2 channels out, and then the chip also has ADC, like DC ADC. So you can use control voltage stuff too. So on this particular, and you've got like 12 channels of possible control voltage. In the case of the adapter thing, I only break out, well actually I'm breaking out all 12, but 6 to 8 of them I'm dedicating to knobs. So you get like 4 to 6 as additional control voltage inputs. But it turns out really nice, and I've got a couple of these actually I've got 3 in my rack right now that you'll hear tonight. These are the Generas, and all 3 of them are programmed to do different things. And I'm using it as this like testing platform where it's like, oh, I want to make this, I want to make that, and I can just try it on this module, and then I can actually just have it as part of my modular, which is really fun. So like, for instance, yeah, here, let me do a really quick demo. So I was playing around with this. So here's like a little synth sound, but then what if instead of putting it straight into the output, I put it into this bit crusher that I made on my Manta Mate. Let's see what that sounds like. Oh wait, that's not my bit crusher. Where's my bit crusher? This one. Yeah. You know, and it's like, ah, that's pretty fun. Or on the same module, since it's got 2 channels in and out, I made the other one be just a different effect, which is this kind of like filter bank modal synthesis kind of thing. It's kind of fun. And it's like, I can just, and actually both of those are, this is actually 150 bandpass filters running set to randomized frequencies, and I can just like change all of those immediately. It's pretty amazing how much you can do on these chips. Yeah.
How do you update your code?
Yeah, so I was actually going to demo it. Let's see if I can. I'm not going to demo it on the Generas that I'm going to use tonight, because that would be a big disaster probably. But yeah. But I have this other thing that I made, which is called the vocodec, and that's just another board where I tried to make it a little vocal processor board I could use with it. And in this case, so let me turn down that and turn up this. So right now I have it running a kind of crappy reverb. What is it? It's woo, woo. Here. Woo. And I made that using this. Yeah, using a PowerPoint. So basically, you just program it all in PowerPoint, and then you just have to have your code in Excel, and you import it. No, sorry, you don't get to do that. But I know that's what you want. But anyway, what it actually does is the way I end up programming it. So yeah, actually I wonder what's the easiest way to do this in the short time I have. But well, maybe I'll introduce the library, and then I'll try to do a little demo. But basically, the other part of it that we made is that's the hardware, and then we were like, okay, let's actually make an audio library so we don't rewrite our code all the time. But the existing audio libraries were mostly C++, or STK is really cool. It's like got a whole bunch of simple functions. We wanted something really lightweight and simple, but we needed it in straight C. You can compile C++ on these chips, but it's not really recommended, or it's a little messier. And I like more memory control. So I wanted to make a super lightweight audio library. So I made this thing called Leaf. It used to be called Oops, but we changed it to Leaf recently. I like the name Oops because it's funnier, but it makes people think it's like more object-oriented than it is. And the idea was totally optimize it for embedded systems. So here's, yeah.
When you say slightly objective,
yeah.
you mean structs with methods?
That's exactly what I mean, yeah. So we designed the whole thing where you have structs, and then you don't have, so in a real object-oriented thing, right, you have classes that have data and functions contained in them. In this case, you have structs that have all the data, and then you pass them into methods that are generic that aren't part of the object itself. So basically like the PD source code or something like that. Yeah, I guess here's a little demo of a project. I was going to show the newest projects using this. So this is the electro bass. You get to see my bass face. Where this is actually 2 of the DSP boards, so that I have a channel for each string for input and output, and then I'm reading I've got like a little trigger strings over here that you pluck and that are just being picked up by magnetic pickups, and then I got like little linear position sensors over there, and trying to make sort of a bass guitar sort of interface. Yeah. This was a couple weeks ago in my studio. Yeah. But it was kind of fun. Like I just sort of put this together over the summer, and it was relatively easy with all the framework that I'd set up already. Or the feedback trombone is another one. This is also using this. This is Weston Alenki. Does anybody know him? I don't know. Great trombonist. So here's him making some noise on it, or it's kind of like this weird. I'm using the DSP board inside the feedback chain of microphone speaker feedback in order to kind of, and then putting that inside a trombone so it resonates with the trombone's frequencies. It's kind of fun. And let's see what else. Oh, and then this vocodec thing. So I made this vocal processor board. That's Mike Mulshine over here. Anyway, that was sort of, that was kind of the most recent thing I've been working on with it, or all these things are kind of simultaneous, but I made this generalized vocal processor. This is another one where I made this thing and I'm like, okay, yeah, does that already exist too? You know, it's like, okay, the TC Electronics has one, Eventide has them, like Boss has one. It's like, I don't know what I'm doing different, but it's nice to be able to make my own from the ground up and actually like know everything that's going on inside it, and then be able to implement any algorithm that I want to test. And the main reason I made it is because the things that existed didn't do what I wanted. And my main reason for making the vocodec was my electro country project. So I needed like I was using a vocoder on stage, but in a computer, and I was like, why on earth am I bringing a computer on the stage when I could just do this in a little box? So I made a little box for myself that takes MIDI, USB MIDI in, and does vocoding really the way that I want it to be. It's with an LPC vocoder, so it's a little nicer quality than a channel vocoder. Here's like on the album, the vocoder on the album is the vocodecs box that I made. And in this case, it's also the other cool things that I can do that you can't do on a normal processor. So for instance, I wanted to make the tuning be in just intonation for the synth, right? So it's like, oh, I can just do that. Here's a little bit of that.
When death shall close these eyelids, and this heart shall cease to beat.
I'll just play a little bit of this song.
And they lay me down to rest in some flowery bound retreat. Will you miss me when I'm gone? Will you miss me when I'm gone? Will you miss me when I'm gone? Will you miss me when I'm gone?
Oh, and this is the bass line that comes in here is the Manta Mate. So I built in some sequencer functionality on the Manta Mate.
On my poor unworthy grave, and come sit.
Yeah, there's a little bit of that.